Hello to everyone listening us on YouTube watching this video. Hello everyone who listens to the Virtual Jack podcast. My name is Alex Live, and I welcome you to the Rebel Labs interview with the VJAG speaker. This week we had an amazing session about the mutation testing of Java code and the PyTest library with the library author Henry Coles. So, hi Henry.
Hey there.
For everyone who doesn't know him yet, you can find him on Twitter under the handle @0HJC, and Henry is the head of innovation at NCR Edinburgh. And for the last 15 years, you've been working as a software engineer at all kinds of systems, from energy trading to finance, and finally you ended up doing the PyTest thingy. So
that sounds like me, yeah.
You are quite a surprise. It's really surprisingly, it's really hard to find any information on you. So if you have any details that you want to share, please welcome to do that. So hi Henry, how was your session today? Did everything work up to your expectations? Anything failed?
I had no expectations, therefore they could only fail to be met.
That's good. That's a good attitude to go into a session, especially with a virtual one. So let's start with the blitz questions that we ask every speaker. Don't try to come up with the best or the most morally correct answer. This is just an opinion. Anything that comes to your head is an acceptable answer. So, is computer science a real science?
Yes.
That's good. What do you like more, static or dynamic typing?
Oh, static, definitely.
What is your favorite IDE?
I use Eclipse. I don't think it's my favorite, but that's the one I use.
Amazing. What is your favorite JVM language?
Tricky one, actually. Probably Java, because it's one I actually know quite well, but I've got a soft spot for Scala as well. I don't speak Clojure at all, but I'd quite like to.
Yeah, it's a nice language. I personally like Clojure a lot. Scala is amazing. What is your favorite? This is a hard one. What is your favorite open source project? And you cannot say PyTest.
Tricky. Well, I guess it needs to be Linux, doesn't it? Because that's been using that for the longest.
Good. Can you just maybe in one sentence describe it? Anyone could.
Linux. It's an operating system. It's quite well known.
It's free and it's working. It's powering the internet. What can you say? Okay. What is the worst thing a programmer can do? What is the worst habit for the programmer to have?
Cleverness. Cleverness is really destructive in a programmer.
Good. So that finishes the blitz questions. So let's go into the longer one about the session and about the topic of mutation testing. So for the last hour, you explained how mutation testing can improve, or at least give you hints how to improve the quality of your test suite. And it's been quite amazing. I actually myself got really inspired to try that, at least on some maybe pet projects of mine. So hopefully that makes you happier about the session. So, but the question is mutation testing actually worth it? Can we maybe replace that with a better type system or something? Do Haskell people, for example, do mutation testing, or should they?
So I can't speak in very little Haskell. It's hard to answer, but actually the author of Mutant, which is a mutation testing library for Ruby, I believe speaks Haskell reasonably well, has been working on a Haskell mutation tester. So certainly his opinion would be that yes, it does make sense to test languages with that strong a type system. I have no direct experience, I can't really comment. But yeah, types will tell you a lot. I think even if you move from something like Idris, they're going to capture everything. So there's always going to be some behavior which requires tests. If you have tests, it makes sense to know if they work.
That's really true. But that brings another problem. So some time ago, just justifying creation of the test was a problem, especially with managers, because, well, tests are actually the code, and to do those properly, you have to invest time and money, and the results are sometimes harder to show than the actual functionality. How can one explain the introducing mutation testing into the project for maybe a manager-like figure. And is that a problem? Do people ask you about that, or I would pass those dark pages now?
I think if you're having to explain to your manager why you're doing something technical, that's your problem, quite frankly. So that's maybe the problem you should be working on is, you should be free to use the tools you think will help. So mutation testing, I only do it because it makes my life easier and makes my code better and makes me more productive rather than less productive. So if it's something which wasn't making me more productive, then I can see why my manager would care about that. But until we hit that point, really, why do you have that conversation? Shouldn't you be able to just get on with the job of producing software?
Do you actually have any experience in people coming to you asking how to do that, or everybody is working at the perfect teams where they can introduce things at will?
I've not had the question yet, so maybe people are thinking it and not asking it. Usually people come to me because they've just heard about mutation testing and are very, very excited. So the questions tend not to be about the manager or the team. It's more, how can I use this? It sounds really interesting. So I get the nice questions.
What is, in your experience, what was the most exciting bug in tests in some project that maybe people, like open source project, you'll know? What was the most hardcore issue that you have caught with that?
Well, it's not really about catching bugs. It's about setting the tests. But I've seen some very interesting sort of repeated patterns. One of the great things about mutation testing system is I get lots of correspondence with people from all over the world about things they simply wouldn't have ever seen before otherwise. So one of the really slightly amusing but also slightly scary things I've seen is test-driven code bases where they say, patches doesn't work, what's going on? It can't possibly be right. And you look at the tests and you see they're using the assert keyword rather than the assertions built into JUnit or any other library. So these tests can never fail unless they enable a JVM flag. So the test driving code obviously never had a failing test. It's these sort of mistakes you wouldn't think of, but you get this lovely sort of, what's the word, much broader experience of code bases just by the correspondence. I quite enjoyed that.
Yeah, that's an amazing story.
So not just once, but several times.
Well, I guess it's an easy pitfall to get into, especially if you receive a project that somebody created first test with that, and then you just copy paste that into other places. So, what other tools can you recommend for assuring the quality of maybe just not the tests as test coverage and what test cases are missing, but assuring the quality of the actual code?
Just the usual things. I mean, so I've been using Find Bugs for I don't know how long. For broad coverage, been using Jacoco for, again, can't remember how long. PMD, I mean, tend to wrap up with Sonar these days, but usually sort of a two-level approach. So you have a slow feedback with Sonar, but then running things in the build still, which get you a bit of faster feedback for the common errors. So even checkstyle is still used, though I used to hate it with vengeance.
Do you have a favorite formatting settings in the, since you mentioned checkstyle and taking that?
I've got a Eclipse format I've been using for donkey's years. It's not necessarily very good, not what I necessarily even like, but this is what I use because I've had it for so long.
Okay, so the default things. Okay, great. I think we are coming to the end of this, so maybe just the last question. The mutation testing concept was, as you said, introduced ages ago, somewhere in 1971 or
71. Yeah.
Good. So, and in academia, and it stayed in academia for the longest time now, because probably we have other problems to solve in the industry. Do you know any interesting ideas from the academia in the recent years or since then that probably won't take until 40 years later as well?
That's a fantastic question, and I wish I had a long list of answers because I'm sure there's an awful lot of stuff lurking there which hasn't really sort of hit the mainstream. I mean, the only one that jumps to mind was an idea I haven't quite found it useful yet, but just seems like it ought to be useful, which is a thing called nanopatterns. So the idea of nanopatterns is, it's kind of what it sounds like. It's just looking for very small, simple patterns in the code. So, for example, one nanopattern is the leaf method. a method that doesn't call any other methods. So it's a tiny little thing you can sort of tag a method with and say, I know this is a leaf. And other ones are things like, I can't remember the proper names, things like state updater. There's lots of, they look at, so you can analyze the code and see these methods have these tiny patterns attached to them. So it's a really interesting project. I've got the name of now, which, the name's gone, but it looks at how the nano patterns attached to methods corresponded with their names. So it's looking for naming errors. So if, for example, you had a method which was void, returned a Boolean and was called set something or other, then this thing would run through and say, okay, the nano patterns that method doesn't match what in the rest of the code base I've analysed. It had like a statistical model of probably half a Maven Central. It ran down, see how do people name methods. They don't match. This might be a naming error. So it's a fantastic idea, really, really interesting. Had a play with it and found out that the only thing it seemed to be very good at finding was things like you could find just by saying with simple rules such as a void method might be called set, but a Boolean method shouldn't be called set, this sort of thing. So, but I'm sure nano patterns probably have a use, just haven't found it yet. There's a guy called Jeremy Singer in Glasgow who's been researching on this. I've met him a few times. I think he'd love to find a use for it as well. So if anyone does find a use for nano patterns, please do let me know.
Yeah, that sounds like a great idea that actually should simplify quite many errors. Well, spotting the errors, especially writing the IDE or something. So yeah.
Or just a way to talk about code as a developer. So say a leaf method, if I'm to explain what you meant, would probably be quite useful. If in the same way, the only real value you ever got from the patterns book was having a language to be able to discuss what we're doing with. And I guess similarly at the method level, having an agreed language could be useful.
Great. Well, hopefully this will get useful and take in the industry much sooner than 40 years later. So thank you, Henry, for the great session and for this interview. I thoroughly enjoyed both of them. So
thank you.
Anyone watching us and listening to us, this was Henry Coles, the author of PyTest Mutation Testing Library for Java. You can find him on Twitter at 0HJC. Hit him with questions and just ponder about software engineering. He has vast experience and he should be able to answer most of your concerns. So thank you all listening to us. Was really enjoying the session, and goodbye. See you the next time.